Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the third lecture of this week 4 for this ongoing course on understanding and reducing greenhouse gas emissions, and we are focusing on scope 1 and 2 emission reduction through building design and construction. This is the third lecture of this week and we are going to talk about accounting methods and data collection. Quickly looking at what we have studied in the previous lectures of this week, we looked at the India specific GHG programs. So, we looked at India GHG program and also the GHG platform India. We looked at the sector wise emission estimates, state wise emissions and also the methodology that has been used to calculate the emissions for each sector, which is actually coming from the standards and existing codes. In this lecture, we are going to be looking at the definitions of accounting methods, what are the different accounting methods, and then steps for accounting and reporting, and quickly looking at few examples of how the GHG emission reduction can be accounted and reported. So, there are examples of how people have already done it. So, starting with the lecture today, we are going to look at the accounting methods. Now, very broadly, if I have to tell you, the accounting methods are categorized into two broad categories. That is how the world is operating when we are talking about GHG emissions. The first one is a consumption based emission and the second one is a production based emission. Now, in a simple language, if I have to explain, the consumption based emission is for a nation or an area of for all the consumption that is happening in this space, whether we produce it or not. And if we look at production based emissions, it is only the emissions which are happening due to the production of the product here in this area. Now, compare it, for example, we have two nations. Nation A consumes a lot of goods, but it does not produce. So, if we look at the direct emissions that are going to happen in this country, because there is no production happening, will be significantly lesser, because the industrial processes, all the industrial units are not situated in this particular nation or country. However, the consumption is significantly higher, but this consumption, the products that are going to be consumed are now being produced in some other country, some third nation, which is where the direct emissions are happening, but they are happening because the product manufactured in the country B is going to be supplied to country A. So, this is the primary difference that we are looking at, and there are a lot of different indicators that we can check while we are comparing consumption based emissions and production based emissions, but a lot of times when the calculations are being done and what we had seen earlier, they are largely the production based emissions, because it is easier to calculate the production based emissions. The direct emissions can be estimated, they can be accounted for, and also the reductions can happen. In consumption based calculations, it is extremely difficult, because then we have to look at the complete trade that is happening, how much of the product consumption goods they are being imported into the nation. So, we have to take a stock of all that is being imported, and then we also have to continue to account for the pattern of consumption, how much is getting consumed, that is, and then of all the goods that are going to be there. So, often the numbers that you will find are production based emissions most of the time. Very few cases are available where we have consumption based emissions also. Now, there is a why at all do we want to have consumption based emissions? Because a lot of countries which you must already be seeing in the world they have become the industries for the world, they are producing for the world. Now, in that case, they will continue to remain the largest emitters also, because the direct emissions are happening where the industries are, and few of the nations in the world are actually producing for the rest of the world. So, the emissions are going to remain concentrated, but are they responsible only for those emissions, or the responsibility also needs to be put on the shoulders of others who are consuming the goods produced from here. So, that is where the discussion or the second approach, which is the consumption based emission approach, is also it is discussed often, but not taken forward because the calculations, the accounting is extremely difficult. If we look at the differences between production based emissions and the consumption based emissions, so we will see that, let us look at the criteria. If we look at the emissions covered, so we are looking at the emissions which are only produced in the administered territory, that is when we are looking at production based, and here we are looking at the global emissions. So, from wherever the product is coming, all the emissions of the product consumed here in this country A, the back home emissions will be calculated together. So, these are global emissions that we are accounting, which is difficult. Also allocation, so we are looking here at domestic production, and in consumption based we are looking at domestic consumption, which is simple, easier to understand. When we are looking at trade, here for production based we are looking at production alone including exports, but definitely not imports. So, we are looking at production which can be consumed internally and can be exported also. So, all of that is included, but in consumption based we are looking at imports and not exports. So, domestic consumption plus the imports that are coming in. If we look at the mitigation focus, we will largely for production based look at the domestic activities including exports, while for consumption based we will look at domestic activities which are resulting in emissions plus imports. Exports are excluded in this particular scenario. If we look at the trade policy here, whether it is consistent with trade policy, for consumption based it is extremely relevant. What is the trade policy? And if we look at production based, it is not consistent, or it is not taking into account the trade policy, it does not require to. Also, if we look at the complexity, production based has much lower complexity, and that is the reason it is often picked up, while for consumption based complexity, for consumption based emissions and its complexity, it is much higher, and that is the reason we often discourage, or it is discouraged from the use. Also looking at transparency, production based emission accounting has much higher transparency because there is greater control and it is easier to account for, while in case of consumption based it is much lower. And similarly, the uncertainties, because the transparency and trust is higher, the uncertainties are lower in production based, while in consumption based the uncertainties are much higher. And that is the reason why the world is going ahead with the production based emission calculations largely. And if you look at the current country coverage as to which countries are going for production based emission calculations, it is relatively higher for the obvious reasons, and the consumption based emission reduction and accounting is much lower with the current data, and that it is easily understandable. Yet the consumption based emission reduction clearly tells us that the producer alone is not responsible for the emissions that are happening. The consumers, the consumer countries are equally responsible for the emissions that are happening in the producer country. So, this whole discussion emerged because we wanted to place the responsibilities rightly. So, the producer is not producing for domestic consumption, he or the nation is producing for the consumption of the consumer nations as well. So, this is the difference that we have to understand, but majority of the times for larger emission considerations we are looking at production based emissions. However, when we are looking at very small facilities, some of the examples we will see in the later slides of this lecture, we will see that for very small facilities and activities, the emission reduction accounting and reporting is largely consumption based. So, for example, if I am a small facility like a club or like a utility building. So, there the consumption is what is my focus, because I am not producing anything, I am just a service sector unit. So, there the reductions are actually being accounted for on the basis of consumption, and the examples we will see. But when we look at the larger perspective, say for example sector wise emissions or the state wise or country wide emissions, then we are largely looking at production based emissions. So, both are working. Consumption based is used where smaller examples are there, it is easier, and production based where we are talking about industries and slightly larger sectors. So, these are the two approaches that are largely taken forward, and both are used in different scenarios, but at a country level when I am talking, it is largely production based and less of consumption based. Now, this is something that we have already seen, but giving you an overview of various GHG protocols and standards. So, quickly going through, we have corporate standard, we have project protocol, we have a specific corporate value chain for scope 3. So, that standard, we have product standard, policy and action standard. So, what is the impact of a particular policy on emissions? So, for example, if you would remember in the context of India I am talking about, so there was in around winters the air quality of Delhi, the NCR region tremendously falls and it is very polluted. So, the government implemented a policy which was the odd even policy. Now, when we implement a policy, if you look at the activity or the policy, it is just a document. Okay. It is just a policy which mentions that okay, alternately it is odd or even numbered vehicle day. What is the impact of this policy? So, this standard actually talks about how to estimate the impact of an action or a policy. So, this is the standard, then mitigation goal standard and global protocol for cities. So, all these standards and protocols we had seen in the initial lectures when we talked about GHG protocol. So, I am not going to go in detail over them, but there are accounting methods for each different types, and there are multiple accounting methods within these documents, and specifically the steps are mentioned for accounting. So, we are going to go over the accounting methods from each of these documents in the coming slides now. The steps will vary for different purposes. For example, if it is policy, the steps are going to be slightly different. If it is a corporate, the steps are going to be different. If it is a city, the steps are going to be different, and also the accounting method. So, it could be one of the two methods which we just discussed, the approaches, and also the steps will vary. So, that is what we are seeing, and reminding you of the GHG accounting principles, they will remain throughout. It is a prerequisite, we cannot compromise on these. We cannot compromise on the relevance, completeness, consistency, transparency and accuracy. For GHG accounting and reporting to be successful, these 5 principles, underlying principles, have to be mandatorily followed. Now, coming to the key accounting concepts that are kind of consistent throughout the use cases and different standards. So, the first thing is identifying what the GHG project is. So, we have to first know what is that project that we are GHG project that we are talking about. So, it is basically, it consists of specific activity or activities, it could be multiple activities intended to reduce GHG emissions, increase the storage of carbon or enhance GHG removals from the atmosphere. So, we are talking about this GHG project. So, for example, I was just mentioning about this policy which was odd even policy. Now, that itself could be one GHG project for the government of Delhi. So, the project is this particular activity or set of activities that we are talking about, or maybe installing the carbon dioxide extractors, absorbers. So, there could be multiple of them. So, where all they are located, what is the capacity at which they are extracting carbon dioxide or other pollutants from the atmosphere or whatever, all this could be part of the GHG project. Or We could also be looking at, say, for example, a university. Now, in this university, for example, IIT Roorkee here. Now, we are looking at reducing the carbon footprint. So, there is no specific activity, there could be multiple activities that we might be doing, but the intent is that this university has to become, say, net zero by such and such date, or similar to that, if the country has to become net zero. So, that itself is a project. So, the project could be very small or it could be very large depending upon the intent, and all the activities. For example, if India is to become a net zero nation, net zero emission nation, it is a huge intent and a target, and there are multiple activities that are within that, but collectively this will be one project. Under this there could be multiple projects, that is what we have to understand. Then we identify, once we know what is the project, we identify the relevant activity. Just like I was mentioning about the project, for example, I am a facility owner, maybe I am a gymkhana owner. For me, the project is reducing the emissions of this gymkhana, and then I could have multiple activities, or I could be undertaking only one activity. That is, for example, I might be changing all the lights in my gymkhana to LED from an existing one. That itself could be a project, it could be as small as that, or so. Now, depending upon this, how many activities are there? In this gymkhana project, there is only one activity, which is changing the LED bulbs. If it is university, if it is institute which is wanting to become net zero, then there would be multiple activities within this project. We might be talking about policy actions in this case. For example, in IIT Roorkee, we mandate students to be having move on either bicycles or on foot. They cannot keep motorized vehicles. Now, that is one policy activity, project activity, and under the policy. The other thing could be that we have installed solar panels on all the academic buildings, on the roofs of academic buildings. That is another activity. We have our hostel messes which are running on solar heat, solar thermal. So, that is the third activity within this project. So, the project is one, but there are multiple activities and so on. So, smaller projects will have lesser activities, the larger projects, for example, nation will have multiple activities, but we have to identify all the activities that are going to be there. Then we have to identify the different sources as well as sinks of greenhouse gas emissions. Now, for example, the gymkhana, the smallest example that I am taking, and here we are only wanting to replace the LED lights. That is one of the activities that we are going to undertake, only activity that we are going to undertake, but it is not the only activity which is the source of GHG or the sink of GHG. So, the source of GHG could be many. For example, this gymkhana might have a small pantry where boiling of water or making of tea or something like that is happening. Now, burning of LPG there is a source of GHG emissions. That is also going to come into accounting. However, the baseline emissions that we will calculate and the reduction that we will show, this activity will not have any impact because we are not changing it. It is not the part of project activity, but we have to account for all the sources within the project and also the sinks. For example, at IIT Roorkee, we created a Miyawaki forest. So, there is a forest. Now, this is acting as a sink, but if the project activity does not include Miyawaki as the proposed activity, the impact of this activity will not be accounted because it will remain constant in both the baseline as well as the reporting year. So, this is what we have to identify, all that is acting as a source of GHG emissions or a sink of GHG emissions is going to be accounted here. And then once we have identified those sources and sinks, we will know and also calculate the GHG effects. What are the primary effects and what are the secondary effects? And then we will define, alongside we will define the GHG assessment boundary. So, the boundary may be defined along with the GHG project and the project activity. Largely it is done there or almost parallelly. So, the assessment boundary has to be clearly defined. What is my organizational boundary that I am looking at and what is my operational boundary. Now, for the Gymkhana, a lot of the customers and clients who would be coming to Gymkhana would be coming from their using their own vehicles. Now, is it part of my organizational boundary or am I including that? That is what we have to see. It will definitely come as part of the scope 3 of the operational boundary. It will go into operational boundary. And what am I doing about it? If nothing, then they remain the same. It is scope 3 emission, but it definitely comes within the assessment boundary. So, that is what we have to define here. And once we have done that, we have to calculate the GHG reduction based upon the baselines. So, we have to identify the baseline year. What is the baseline scenario? We have to know, calculate the baseline emissions clearly, and then we have to calculate the GHG reductions. So, we have already seen how to define a baseline year. It could be defined on the basis of the intervention taking place. So, prior to the intervention and post intervention, or it could be an example year, or it could also be an average of a period. The baseline emissions could also be an average of say 3 years or 5 years to give a more reliable baseline data. So, that is also a possibility, not necessarily just 1 year, it could be an average of 3 years or 5 years which can be used as a baseline. Then we also have to define the valid time length for the baseline scenario. For example, we are in 2023 today. Suppose India says that we will become net zero, that is an absolute intent, but if it says that we will reduce the emissions by 50%, 50% of which baseline scenario, 50% of what? So, that is the baseline scenario and it cannot remain same. For example, today the world cannot say that we will be reaching the emission levels of industrial era, which is probably reducing the emissions. If we look at the baseline scenario of 2000, which will be like reducing the emissions by 300% of the 2000 year baseline, if we have to reach 1800. Or if we go further and if we are able to reduce the emissions, then 2000 will not serve. If we start to reduce the emissions, then the baseline has to be shifted further ahead in time to actually make set the realistic goals. So, the validity period of this baseline scenario also has to be discussed properly, scientifically, and decided, put in place. Then we also have to look at dynamic versus static baseline emission estimates. So, sometimes we can just have static baseline and have a validity of time for this baseline scenario to remain valid. Else we can have dynamic baselines, which is for every year we will have the baseline as the 5-year average, the previous 5-year average, or the previous 10-year average will serve as the baseline for this year's reduction. That is also a possibility. So, this, if we have a dynamic baseline, it will continuously improve, it will be like a linear thing. If it is a static baseline, it will be a stepped approach that we. So, if we have a static baseline, then we have a static baseline, we have a time period to it. So, there is a reduction in the emissions, and that is where we will reach. Then we will set another baseline and we will further reach down. So, it will be coming down like this if we have to look at the static baseline. If we are looking at a dynamic baseline, then the average of previous 10 years becomes the baseline and we reduce, and the previous 10 years becomes the baseline and we reduce. So, it almost becomes linear. So, that is what we are talking about. So, it almost becomes linear and here it distinctly becomes a stepped thing. So, we have to we have to see that depending upon the project and the activities that we are undertaking, which kind of baseline is more relevant and useful. For example, in case of IIT Roorkee's case, as I said, we installed photovoltaics and we also installed the solar thermal, the dishes. Now, the baseline for that could be say 5-year, the average of 5 years before the installation happened, and then I can calculate the reductions post that. While in case of plantation, drive, we could look at the dynamic baselines, because we may be planting every year 50 trees, 100 trees every year on the campus, and we can continue to shift the baseline, make a dynamic baseline. And then we have to look at the equivalence of products and services. Not all products and services will be giving us the GHG emissions in direct form. So, we will have to establish the equivalence. A lot of work has already been done to give us the emission factors, to give us the equivalence factors, and they are more or less available in different country specific standards. So, we can pick up that for different products and services. And finally, additionality, where we should be able to add on activities and continue with our GHG calculations. So, these are the key GHG project accounting concepts which we will use when we are accounting for any project or activity. And what we are going to do when we say GHG accounting and reporting, we very simply, we are calculating the GHG emissions for the base year, whatever that year is, and we will calculate the GHG emissions for the current reporting year, and the difference between the two is the GHG emission reduction that we are talking about. Now, if we are talking about the policy aspects in this particular standard, which is about policy and action, as I was mentioning, it is taking into account, or it is accounting and reporting for the impact of the policy decision directly on the GHG emissions that are taking place. So, as I had given you the example, there are several examples that are going to be that you can think of, and all we are doing is this. So, we are looking at the total net change in GHG emissions that are resulting from the policy or action specifically. And how are we doing that? We will look at the total net policy scenario emissions minus the total net baseline scenario emissions, and that is where we will know that how much of the net change due to this policy has been there. Negative number gives us reductions. Positive numbers due to the use of certain policy could also mean the increase in emissions. So, here we are talking about GHG emissions. It could be done in similar manner for other resources as well. It could be for water consumption, for energy consumption. Here we are looking at GHG emissions. So, for example, the fleet of buses, the public transport changing from the diesel buses to electric buses. How much is the difference? Now, calculations, when we say accounting, there will be a lot of data that will be going in. For example, this fleet of buses by the public transport department of a particular city. How many buses were replaced? So, prior to that, if we had 100 diesel buses, each bus will ply for almost x kilometers every day, and per kilometer this much is the emission, GHG emission that it causes. That was the baseline scenario, x, y, z year, or the average of 5 years. Now, in the proposed project activity, we replace 50% of the buses by electric buses. So, 50 buses will be now running on electricity having so much emissions, 50 buses running on diesel having this much emission, the direct emissions, and we will also calculate the scope 2, the indirect emissions which are resulting due to the use of electricity here. So, that is also going to be there. And in the scope 3, we might be looking at what happens to these 50 buses which may have been rickety or out of use. So, if we are dismantling and disposing them, so that is also coming as scope 3. What happens to that? If it is going for recycling, if it is going for whatever dismantling process and disposal process, so that is also going to be accounted for in these emissions. from this to this, and on top of that we will also have transitional costs. But these are the policy aspects of GHG project accounting. So, whenever we are taking policy action, we are also going to be looking at the the concepts which are related to this particular policy action. Now, for different standards, there are steps for accounting and reporting which are going to be there. If we look at the generic process, the first thing we will do is we will define the GHG assessment boundary, that is after we have identified the project and project activities. We select the baseline procedure and identify the baseline candidates as we have just talked about, and we estimate the baseline emissions, which could be project specific procedure or the performance standard procedure. Either of the two procedures we will use. We can be using specific project specific procedures. The information that you could find, a lot of information related to this you could find on India GHG program. So, sector specific, industry specific, project specific procedures and activities are going to be considered here for calculating the for estimating the baseline emissions. In case of performance standard procedures, we will be using the standardized, the average numbers for the industries or for the activities, and going ahead with estimating the baseline emissions. This will give us the GHG reductions from baseline to the accounting year, to the reporting year, and then we will take it to reporting the GHG reductions. This is the specific, this is the generic process, and then the activities within this. For example, the estimating the baseline emissions, what all activities are going in, what are the emission factors, what are the emissions that are taking place, the specific procedures or the specific numbers or the average numbers, all this is going to, a lot of work is actually going to happen here when we are calculating, when we are estimating the baseline emissions. So, we are identifying the activities and then estimating the emissions. Now, if we look at the accounting and reporting and the steps for only scope 3, so it is very similar. This particular accounting method, these steps are given in this corporate value chain scope 3 accounting and reporting standard, and they are very similar to what we have just seen, but they slightly vary. For example, in this one we are defining the business goals very clearly first, while in the previous one we directly went ahead with identifying the project and defining the boundaries directly. Here we are first defining the business goals and then reviewing the accounting and reporting principles clearly. After that we are identifying the scope 3 activities and scope 3 boundaries. So, before that we are defining the business goals, because the scope 3 activities will actually be dependent upon the goals of the business. What all do we take into account in our scope 3 will depend upon the business goals. What all activities can be encompassed, not all, because at the end of the day if you look at this, every business will probably be affecting hundreds of activities and businesses across, but all of them they cannot be accounted for. Post that, more or less it is a similar process where we collect the data, we allocate emissions, we might be setting a target or not, it is not necessary, but we actually track the emissions. So, we are estimating the emissions for the baseline year and then for the reporting year, and then tracking the change, the difference in the emissions, whether they are reductions or not, and then assure or not necessarily like the validation or third party validation, else go to the reporting. So, pretty much the same except for the first two parts where we are first defining the business goals to know which all activities should be covered in scope 3, because scope 1 and scope 2 are very clear. Scope 1 we know direct emissions, no confusion. Scope 2 is clearly the purchased electricity emissions. So, that is also very clear, but scope 3 emissions can include a huge range, a wide range of activities within it, but are they really coming within the organizational or operational boundary depending upon the business goals or not is what we are ascertaining. for this particular scope. There is another standard which is on product life cycle accounting and reporting standard, and it is very similar to the life cycle assessment. But in life cycle assessment, if you have gone through, we are actually looking at the environmental impacts, the impacts on environment plus a lot of other factors throughout the life cycle of a particular product. Here in the product life cycle accounting and reporting standard, we are doing pretty much the same, but only for one thing, which is GHG emissions. So, we are taking into account the entire life cycle of a product or the activity that we are looking at, but we are only looking at the GHG emissions that are associated with it throughout its life. And if we compare, it is pretty much the similar steps. So, if we look at the LCA study, compare it with the steps in GHG inventory for product life cycle, we will see that they are similar. Here we are defining the goals and scope. In this one also we have to define the goals and also the fundamental principles of life cycle accounting. After this, for ISO LCA, we look at we develop the inventory, we look at the life cycle inventory, and here we define the boundary as we always do, and we collect the data. So, that is also defining the boundaries is also taking into account the entire life cycle of the product, and we collect the data. Then we go ahead for impact assessment, and here we are looking at the inventory results. So, calculating it between baseline year and the reporting year. Interpretation, here we are looking for performance or reporting or validation, and finally leading to reporting. So, they are very similar. So, this particular standard actually draws a lot from the ISO standard, and they are very similar. The only thing being that we in this particular standard, we are following steps only to account for the GHG emissions and nothing else. Now, once we have looked at the steps of accounting and reporting for different standards, different activities and products, let us quickly go through some of the examples of accounting and reporting. Now, these largely are consumption based emission reductions. This one is indirect emissions from purchased electricity. So, if we are purchasing electricity, so then what are the different types of emissions that are going to happen, where all and which scope do they go. So, if we are a utility or service which is purchasing electricity, there could be own consumption, resale to end users, resale to intermediaries. For example, we might be a distribution company, we do not produce electricity, we only purchase electricity and then transmit it and we distribute it. So, own consumption, the emissions from that are still going in scope 2, because we are not producing electricity, we are still purchasing electricity. Resale to the end users. Now, this electricity has now become a product which is going to the end users, and how they consume. So, all the emissions that are accruing from their use are actually going in scope 3. For example, we purchased 100 units of electricity, 5 units were consumed by us. So, the scope 2 will have only the emissions related to these 5%. If resale to the end users is say 80%, then the 80% emissions will actually go in scope 3, how the users use it. And then there could be resale to intermediaries, that is also going, it can be included in scope 3 or it could be in optional information depending upon the organizational boundary and the business goals. If we look at the complete cycle of from production, transmission and use of electricity, and we look at where each scope can be defined. So, if you look at this, the coal mining, processing and transport, all the emissions related to that are actually scope 1 emissions. For whom will they be scope 1? We will see. When the coal is brought to the power generator, there are direct emissions, they will also be scope 1 for somebody. When it goes to the utility, then it becomes scope 2 after that when it is used, and at the consumer end also it will largely remain in scope 2. Now, if we look at this entire cycle from production, transmission to the use of electricity, there could be 4 different parties that could be involved. 1, coal mining, processing and transport, power generator, utility and end consumer. Now, If we look at the coal mining process and whatever 5 tons of carbon dioxide equivalent that is generated will be scope 1 for the coal mining processing and transportation company, because it is directly getting those emissions, while for others this will become scope 2 emissions. For a power generator company, the company B which is generating power in thermal power plant, the 100 tons of carbon dioxide that is going to be released is actually the scope 1, and for them the 5 ton will become the scope 3, because it is the upstream activity that is going to happen. So, that 5 ton is actually going as scope 3, and for this company this 100 ton is going as scope 3 activity. For the utility company, whatever the generation of whatever emissions are happening from the generation, that is actually either going in scope 2 or scope 3, because they are only distributing, it is the utility company. For the end user, most of this, because in this case the utility company is not using the electricity that it is purchasing, the 100 tons here. The scope 2 is only from the emissions which are accruing from the energy that is being consumed in the facilities of this utility company, and the rest is also going in scope 3 for this company. For end user, because he is consuming this, it is going to be a scope 2, and the rest is going to be the scope 3. So, this is a clear understanding which you get depending upon the business goal or the scope of this particular company, the boundary that we define. So, same, all these activities are actually for one value chain, which is generation, production, distribution and use of electricity, but depending upon who the user is, who the user company is, the scopes will vary. However, if you look at it in totality, if everybody looks at their scope 1 and 2, we will be able to account for all the emissions that are happening in the entire value chain. Somebody somewhere will be looking at accounting for these emissions. If end user looks only at the scope 1 and 2, if utility company looks at only scope 1 and 2 and like this, we will still be accounting for 100% emissions that are happening in the entire value chain. And that is why today largely the world is focusing on scope 1 and 2 emissions, and even when we are not having a lot of clarity on scope 3 activities sometimes in our value chain, it is still being encouraged that companies go for scope 1 and 2 reporting, if not scope 3, which is a large value chain. We can look at quickly some examples. For example, there is this nursing home which is now connected to a solar panel facility that is not connected to an electricity grid, but it is owned by an industry, and the industry is giving them the surplus energy. In that case, the energy consumption earlier, if it was happening due to consumption of electricity from grid, depending upon the emission factor, we will get some carbon dioxide, and now this emission factor has turned to 0, because all this energy is now being supplied from the renewable source, that is solar. So, that is how the reporting of each specific activity will happen within a project. So, this project could have only one activity or multiple activities. We will know the difference, how much is the emission reduction. This is similarly another example where there is the swimming pool, there is swimming club, where the heating of water was happening earlier through energy, through natural gas boiler, and now they have installed a domestic hot water, solar domestic hot water system, which supplies some percentage of the total energy that is required. So, we will calculate how much was the original production of carbon dioxide, the consumption of natural gas per year, and what is the reduction that has happened because of installation of solar water heater, and what is the resulting carbon dioxide and hence the reduction. So, simple activities. So, for a bigger project we must and we should divide it in smaller activities and calculate it like that. This is another one where if a home has changed its its boiler, which is based upon natural gas, to a newer one, more efficient one, where it reduces the consumption by 5%, how much is the reduction in the carbon dioxide emissions that are going to accrue from this change, and hence the reduction in GHG emissions. So, similarly, we can look at specific activities within a larger project and calculate the overall GHG emission reduction. So, I hope we are very clear about the accounting, what are the different approaches to accounting, what are the different steps to be followed, methods, and how do we go ahead with accounting in this lecture. Thank you very much for joining me. See you again tomorrow. Bye-bye.